Thank you, Karen. This is Dan Johnson, and it's a pleasure to be here this morning with everyone. Today, Dave and I are going to discuss one of our projects at PNNL and provide just enough background information for you to understand what we engineered, but we're going to focus on the process that the team developed to successfully deliver a working system, a process that embedded an agile development approach within a plan-driven hierarchical project lifecycle. Our work was on a research and development project that had a deadline to build a functional prototype for an operational system. Given the nature of the research, we felt that following a traditional hierarchical approach created an unacceptable probability of failure. We needed a development framework that would allow for more flexibility and adapt to the results of the research and ultimately to our changing requirements. Dave and I proposed to the project management team the idea of using an agile engineering framework. Our proposal was accepted, and the process we developed for our team is the primary emphasis of this presentation. And finally, in our conclusion, we'll share some items in retrospect now that we've had the opportunity to look back on the project. Dave and I joined the new project team about the same time in the fall of 2012 that largely already had a plan in place to develop a novel sensor-based correlation software architecture for two related projects for the U.S. Department of Defense and the U.S. Department of Homeland Security. The objective of the new system was to integrate physical sensors and apply the detections as inputs to a correlation and threat assessment software architecture. The architecture would support the various systems to perform risk analysis and assessment of targets. This system of systems would then be integrated with a larger command and control system in support of military-based defense. The physical sensors were disparate, standalone systems that had not been built to contribute to a larger integrated multi-sensor system. Software development started with proof of concept, multi-sensor correlation and assessment code. Our goal was to evolve the code and provide an intuitive, risk-based operator interface that integrated and fused the results from the standalone sensor assets. The project integrated 5 different sensing technologies, a tracking technology, plus the initial correlation and assessment software. It was expected to meet key performance parameters defined by our client. A third party was selected to perform independent verification and validation tests at an external site. As a subset of a larger program, our client employed a plan-driven, requirements-based methodology. Gates for transition to the independent V&V test required PNNL to conduct live demonstrations of end-to-end system capabilities and documented compliance with system performance specifications using structured verification methods. Limited access to the standalone sensors, plus the effort and cost to establish and conduct the IV&V testing were additional challenges that the project team faced. The project had a strong front-end systems engineering focus. We had defined user needs and capability gaps from the client. PNNL developed the operational requirements document, completed an analysis of alternatives, and determined the system architecture. From this, the performance specification was developed, and we established and maintained requirements traceability and verification matrices. The challenge in front of us was how to effectively develop a solution while we were concurrently researching existing sensor capabilities, working with others to extend their sensor capabilities, developing a software architecture and a suite of software applications, and preparing for IV&V activities. Our plan was to regularly test what we had, inspect the results, determine the viability of each and every sensor, and the performance of the architecture, and adapt to the results throughout the project lifecycle.